That is the maximum static friction.
693.
Yeah.
Okay.
And then that's the friction.
Okay.
Now, the reason, a reason not to put in numbers yet, wait till the end to put in numbers, is because if the problem changed as such, so I put the mass on the ramp and I notice that it doesn't slide. What I now want to do is add a little bit of oil, and oil sort of seeps in through here, and it changes these drastically. This now becomes 0.3, that becomes 0.2. Will it slide down? Well, nothing changes until we get to here. That 0.8, using the magic of different colors, that becomes 0.3. And so it's going to be a positive number, whatever it happens to be.
2.402.
One more time.
2.402 meters per second squared.
But is that the acceleration of the object?
No.
Why not? You are correct. It is not the acceleration of the object.
Because what we solved for is not a vector. No?
We know it's moving because we put in the static friction, so you can put in the kinetic friction.
It is going to overcome the maximum static. Therefore, since it overcomes the maximum static, it is going to slide. And so we have to use mu sub k. So you could go through and put a k instead of the s's, or just come through here and put in 0.2. So is it moving? No. Acceleration is 0. Assuming it starts at rest. Acceleration is 0. Sorry, what'd you get?
3.268.
268.
Not this part. Just the part inside the box. I know the answer.
The part of the box is 3.268.
Well, the whole thing with the 10.5 is 3.268. But you just mean 2 times 10 times 0.866.
Yeah, well, I was looking for the whole thing. So
Oh.
that sounds like we're there. All right.
Meters per second squared.
What'd you say?
Meters per second squared.
It's acceleration. Not written in a traditional way. Maybe it's usually not written over the number. So that is the actual acceleration.
Wait, I'm sorry. So why is it not 0.3?
0.3 was the static coefficient. When we plugged in the maximum static, we got a positive acceleration. That was the 2.402. Therefore, it is going to accelerate down the ramp. Once we establish it will accelerate down the ramp, that tells us that the object will slide. Therefore, we should not be using static, we should use kinetic. And so that's when the 0.2 comes in. That's the static coefficient. As we can do a flow chart here. Moving. Yes. assume acceleration is in the correct direction. Yes. Therefore, acceleration is equal to 0. No.
Does that say with?
Yeah, with Fs max is acceleration less than 0. I guess less than or equal to. Maybe we're right at that critical point.
So last class you talked about a graph where if it reaches like the maximum static, it breaks and it goes to kinetic, right?
Right.
So is the value when you were solving for the static and then solving it inside the equation, was that like the breaking point of the static? Is that what we were solving for?
Yes, Fs max is the breaking point.
Okay.
So it's a question of if I'm using the breaking point, so that was the graph that we had. Is in essence, I have this is my maximum static, and I have my applied force. Where's the applied force falling? That's in essence is what we're doing.
So like the negative 1.928, that's like the maximum static force, but since it's negative, it's not possible.
Using the maximum static friction, we got an acceleration of negative 1.9, which is does not have physical meaning.
Okay.
You were in it, don't worry. Okay.
Okay. Questions to hear?
What is in that box right there? That big box? Yep.
That one?
Yeah.
With Fs max
Okay.
is the acceleration less than or equal to 0?
Okay.
Question mark. All right, so having gone through all this, when there was no friction, what was our acceleration? Did we do that one? The no friction?
Would it just be W sine theta? No.
It would just be g sine theta.
Oh yeah.
So that would be 4.9 meters per second squared. So if this were a lab, and we had ended up with A equal to 5 meters per second squared, what would that tell you?
The ball is moving 5 meters second squared down the ramp.
Yeah, but if without friction, it should be 4.9-ish. But we got 5.
Then it's moving at 0.1 meters per second squared then in total?
No.
Oh.
Don't forget the intro was if this were a lab.
Then we had something about our experiment caused it to slide more easily or like reduce a little bit of the friction.
Oh, it's more than just friction's been reduced. As the friction increases, so if ideally, if it should be 4.9 meters per second squared, if friction increases, is that acceleration going to go up or down?
Down.
Yeah.
Okay. So if I'm getting better than if I expect with friction, or in a frictional situation, what is that telling you experimentally?
There's no friction.
Okay. Anyone else?
An answer's an answer.
All right. It could. I mean, it's possible. You know, it's a lab, physics lab. Don't expect numbers to be perfect. So it could be that there's a miscalculation somewhere. It could be that there's no friction, or the friction is so low that any tiny little statistical fluctuation is caused, just in this case, for the acceleration to be better than expected. If acceleration were 4.5 meters per second squared, what would that tell you?
So if there's more forces of friction
Yeah.
at play.
Or just there's
More
frictions involved.
Yeah.
This will be relevant in the lab. So what we're going to do is we're going to mosey on down there. It is a fun-packed rolling carts down a ramp.